What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 13, Section 2, Arithmetic Sequences. Let's do it. First question is, what is an arithmetic sequence? So an arithmetic sequence is a sequence of numbers when there's a common difference that you're either adding or subtracting to get each successive term. So one example would be 1, 3, 5, 7, right? The common difference is positive 2 every time. Another example would be 10, 7, 4, 1, negative 2, etc. Every time the common difference is negative 3. So that's an arithmetic sequence. That's how you do it. Done. How do we determine whether a sequence is arithmetic? So again, what you're going to do is you're going to look at the sequence, right? We'll say like 2, 5, 9. Let's take this as an example. We're going to look at the common difference between each successive term. So here we've got 3, here we got 4. They're different. They're not the same, so this would be a no. But then if we had 5, 9, 13, 17, like this, right? And we're like, oh, it's 4 plus 4 plus 4 every time. Then we'd say yes. So that's how you'd make the determination. Describe how linear functions and arithmetic sequences are similar. How are they different? So a linear function is the same in the way because like there's a constant slope. Take this example, y equals 3x plus 5, right? So every time there's going to be, as we kind of increment the x value by 1, 2, 3, right? When x is 1, here I'll make a little table. When x is 1, y is going to be 8. When x is 2, y is going to be 11. X is 3, it's going to be 14. So you see we have a common difference of 3 like this. So that's the similarity. The way it's different is a linear equation. We can plug in anything for x. It doesn't have to just be whole natural numbers, right? It could be like 1.7, 3.2. We don't have that in an arithmetic sequence. For an arithmetic sequence, you're going to have 1, 2, 3 for the actual number in the sequence of terms, right? So anyways, that's how you do it. Done. Here we're meant to find the common difference, and you can look at any two consecutive terms. I could look at 1 and 3 halves, and that's going up by 1 half. That's the common difference, but it'll be consistent here as well. That's adding a half, that's adding a half, as it should be. So the common difference is 1 half. Done. So for this one, I can figure out right away if it's an arithmetic sequence. Right here, we have a common difference of plus 12. And then right here, look at that. We have a common difference of 48, okay? So right off the bat, I have two different common differences. I don't have to check anything else. So this would be a no, okay? So that's how you do it. Done. So here we want to write the first 5 terms of the arithmetic sequence given the first term and the common difference. So we've got 1, 2, 3, 4, 5, and it's telling us that the first term is 0. Every time we're going to be adding 2/3. So what I'm going to do is I'm going to first write it without simplifying anything, and then maybe we'll simplify if need be. So we're going to add 2/3. So the second term is 2/3. Third term we're going to add it again is 4/3. Fourth term we're going to add it again is 6/3. And fifth term we're going to add 2/3 again, and we have 8/3. So just to rewrite it, we can say 0, 2/3, 4/3, 6/3 is 2, so I'll write it as such, and then 8/3. So these are the first 5 terms. Done. So for this one, we want to write out the first 5 terms. We're only given the 13th and the 33rd term. So what we can do is we can use this to find the common difference. I'm going to show you how. So normally we'd say a sub n, or let's say a sub 13 is equal to the first term plus whatever my common difference is, which we don't know, times n minus 1. And in this case, n is 13. So we have 13 minus 1. Then we can make a second equation with a sub 33, and we can say a sub 33 is equal to, again, a sub 1 plus the common difference times 33 minus 1, right? N minus 1, so 33 minus 1. Now we know that a sub 13 is actually negative 60, and we know a sub 33 is negative 160. So check this out. We now have a system of equations with 2 unknowns. So what I'm going to do is I'm going to multiply the bottom one by negative 1. Negate, negate, negate. And when we add these together, we're going to get 100. These are going to cancel out. Let's go ahead and distribute these d's here. So here, oh, but actually not really much to distribute. 13 minus 1 is 12 times d is 12d. This is 32 times negative d is minus 32d. Now we get 12d minus 32d is negative 20d. Divide by negative 20, and we get the common difference is -5. Okay, so there's our common difference. We still need to find the first term, so we can plug this common difference back into either of these equations and solve for a sub 1. So let's plug it into the top one. So if we got -5, we got -60 is equal to a sub 1 minus 5, because it's -5, times 13 minus 1, which is 12. All right, so -5 times 12 is -60, so we got -60 equals a sub 1 minus 60. These are going to cancel out. A sub 1 equals 0. All right, now we can get the first 5 terms. Here we go. First one is 0, as we found. Then we're going to be minusing 5 every time. So we got -5, -10, -15, and -20. These will be the first 5 terms. That's how you do it. Done. First term is 4, common difference is 5, find the fourth term. So we could do this a couple different ways. We could use a formula, or we can just kind of start with the first term and add 5. I'm going to do that because it's going to be a little bit quicker. So the second term is going to be 9, the third term is going to be 14, and the fourth term is going to be 19. So anyways, that's how you do it. Done. So here we want to find the sixth term. Again, I can use either a formula, or I can actually put 6 and then add 7, so on and so forth until we get to the sixth term. This time I'm going to use the formula. So a sub n is equal to the first term, which is 6, plus the common difference, which is 7, times n minus 1. So here's my baseline formula for an arithmetic sequence. So if I want to find the sixth term, I'm going to plug in 6 for n. So 6 minus 1, that's 5, times 7 plus 6, that's 35, plus 6, which is 41. That's how you do it. Done. So for this one, we're meant to find the first term of the arithmetic sequence if we know the sixth term is 12 and the 14th term is 28. So what we can do here is we can use our formula, which is a sub n equals a sub 1 plus the common difference times n minus 1. Now, we don't know the common difference and we don't know the first term, but we can figure it out from here. So I know that the 14th term is 28. So I can say 28 is equal to a sub 1 plus an unknown common difference times 14 minus 1, because n is 14. So 14 minus 1, like so. Then for the second equation, I can say 12 is equal to, again, an unknown first term plus common difference times 6 minus 1, because that's the sixth term, right? So we can simplify this a little bit. That's 28 is equal to a sub 1 plus 13d, and then we've got 12 is equal to a sub 1 plus 5d. All right, now if we want to find the first term, we basically have a system of equations. What we can do is if I can eliminate the d, I can solve for a sub 1. So let's do that now. I'm going to multiply the bottom equation by 13. I'm going to multiply the top equation by -5. So check this out. -5 times 28, that's -140 equals -5 a sub 1 plus, and the -5 times 13 is -65d. Just barely got enough room there. All right, now we're going to do the bottom one. 13 times 12, that's 156 equals 13a sub 1 plus positive 65d. So when we add these together, these are going to cancel out. -5 plus 13, that's positive 8a equals -140 plus 156 is 16. Divide both sides, and that's a sub 1, by the way. Divide both sides by 8, and we get a sub 1, which represents the first term, is 2. That's how you do it. Done. Find the first term, or a1, of an arithmetic sequence. As we got the 8th term is 40 and the 23rd term is 115. So what we're going to do is we're going to make a little system of equations. Again, I'm going to have a sub n, in this case a sub 8 is 40, is equal to, right, the formula is always a sub 1 plus the common difference, which is unknown at this case, and then we've got n minus 1. In this case, n is 8. So we got 8 minus 1. And then down here, we got a similar thing. 115, again, equals that first term plus our common difference, which we don't know, times this term. That's n, 23 minus 1. Now, to simplify, we got 40 times 40 equals a1, and then d times 7. So 40 equals a1 plus 7d. This one is 115 equals a1 plus 22d. Okay, now we're going to use elimination, and first we're going to solve for d. So we're going to go negate, 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 multiply everything by -1, add them together. A1s are going to cancel out, right? -a1 plus a1 is 0. -40 plus 115 is 75, is equal to 15d. Then we're going to divide both sides by 15, divide by 15, and we've got d is equal to 5. If d is equal to 5, now we can find a1. Let's plug and chug right here. a1 plus 22 times 5, which is 110. 115 equals a1 plus 110. Last but not least, subtract 110 from both sides, and we've got a1 is equal to 5. So that's the first term of the sequence. That's how you do it. Done. Find the first term of the sequence if A11 is 11, A21 is 16. All right, let's write this out. So the 11th term, 11, is equal to my first term. And then we've got the common difference times n minus 1. In this case, n is 11, so 11 minus 1 is 10. There's our first equation. Second one is 16 is equal to A sub 1 plus the common difference times n minus 1. In this case, 21 minus 1 is 20. Now we got a system. Now let's solve. We're going to multiply by negative 1 so we can eliminate the a1s. Add these together. Negative 11 plus 16 is 5. These are going to cancel, and that's equal to positive 10d, which means my common difference divided by 10 is therefore 5/10 or 1/2. Now we can use this to solve for a1. So we're going to plug and chug down here. 20 times 1/2 is 10. So then we got 16 is equal to a1 plus 20 times 1/2, which is 10. Last but not least, minus 10, and a1 equals 6. And that's how you do it. Done. So for this one, we're trying to find the 21st term. So again, we can make two equations. Check this out. We can say a sub n, which in this case will be 3, which we know is negative 17.1, so we can write that out, is equal to the first term, a sub 1, plus my common difference, which I don't know yet, times n minus 1, which would be 3 minus 1, which is 2. And then over here, we're going to have a sub n, which the 10th term will be negative 15.7, is equal to my first term, plus the common difference times 10 minus 1, n minus 1. So 10 minus 1 is 9. Now we have a nice system of equations. Now we can combine and solve. So I'm going to multiply the bottom equation by negative 1. So we got positive, negative, negative. So set negative 17.1 plus 15.7 is negative 1.4 is equal to, those cancel out. And then we got negative 9d plus positive 2d is negative 7d. Divide both sides by negative 7, and we've got d is equal to positive 0.2. So if my common difference is 0.2, I'll plug it into the top equation, and we've got negative 17.1 is equal to a1 plus 2 times 0.2 is 0.4. Last but not least, minus 0.4 from both sides, like so. And we've got a1 is equal to negative 17.5. Now we have enough information to find the 21st term. So going back, now we have our main equation for the sequence. A sub n is equal to my first term, negative 17.5, plus my common difference times n minus 1. So now we're trying to find the 21st term. So I plug in 21 here, and I evaluate. So 21 minus 1 is 20. Let's write that up here. Sorry, I know it's all over the place. So we're going to write 20, because again, that is 21 minus 1. And then this times 0.2. And then we're adding this to negative 17.5. And that's going to give us our answer. So 0.2 times 20 is 4, so negative 17.5 plus 4, which means our a sub 21 is equal to negative 13.5 for the win. Boom, done. So here we got our first term, which is negative 19. Now to write the next 5 or 4, we're going to use this recursive formula. And what it's saying is we take the previous term, and to get the next term, we're going to subtract by 1.4. So negative 19 minus 1.4 is negative 20.4. Then to get the next term, we're going to do negative 20.4 minus 1.4, which is negative 21.8. Then minus 1.4 is negative 23.2. And last but not least, minus 1.4 is negative 24.6. And that's how you do it. Done. So for this one, we're meant to write a recursive formula to represent this sequence. Now, for any arithmetic sequence, we have to first identify the common difference. So what is the common difference? It looks like it's going up by 9 every single time. So what you can then notice is to go from each previous term, which we'll say a sub n minus 1, to the next term. All we're doing is we're just adding 9. So that's your recursive formula. That's how you do it. done. And by the way, we should put the preconditions that this recursive formula works assuming we set our first term to 17, and as we plug in n values, we're plugging in n values that are greater than or equal to 2, right? We don't want to plug in 1 and get a sub 0 or negative or things like that. So anyways, that's it. So for this one, we first need to identify the common difference, and it looks like every time it's going up by positive 5, right? So now to get our recursive formula, meaning to get the next term, we take the previous term, a sub n minus 1, and simply add 5 to it. And now the only other preconditions that we need to mention is that a sub 1 would have to be 12, and we're assuming that n is greater than or equal to 2. And that's how you do it. Done. So for this one, we have to identify the common difference, which it looks like it's going up by 1.4 every time, 1.4 every time. So therefore, to get each subsequent term, we take our previous term, a sub n minus 1, and add 1.4. And again, this is contingent on the first term being equal to 8.9 and the n value being greater than or equal to 2. And that's how you do it. Done. So for this one, we want to try to find the recursive formula, and we need to see how it's changing every time. To get a better idea, I'm going to get some common denominators. So that's going to be 4 over 20, right? Multiply top and bottom by 4, 9 over 20, and then double it up here, and we've got 14 over 20. So what you can now see is every time it's adding by 5/20ths, right? 5/20ths, or which reduces to 1/4. All right, so that's my common difference. Therefore, my recursive formula is that each previous term, a sub n minus 1, is going to be added to 1/4 to get the subsequent term. So there's your recursive formula. Now, that's assuming that we start with a1 is equal to that 1/5, and n, as per usual, is greater than or equal to 2. That's how you do it. Done. So for this one, before we get started, we're going to take a closer look at these numbers with common denominators. I'm going to make 1/6 2/12. I'm going to leave that as negative 11/12. So we're going to make negative 2 negative 24 over 12. So now we can see a little bit better, especially between these two. It looks like we're going down by 13/12. So negative 13/12 is the common difference, which means the recursive is a sub n equals the previous term, a sub n minus 1 plus negative 13/12, or we could say minus 13/12, like so. And again, this is assuming that a sub 1 is that nice 1/6 and n is greater than or equal to 2. That's how they do it. Done. So for this one, we're meant to write a recursive formula and then find the specified term. So it looks like the common difference here is 7. It's going up by 7, and a1 is equal to 4. So our recursive formula would be a sub 1 is equal to the previous term, a sub n minus 1 plus 4. Okay, now to find the 14th term, we have the first, second, and third term. Of course, this would be easier with the explicit formula, but let's play it out and we'll find the 14th term. So we got 1, 2, 3. I'll write it out. 4, 5, 6, 7, all the way through 14. So adding by 7, it would be 25, 32, 39, 46, 53, 60, 67, 74, 81, 88, last but not least, 95. So that would be the 14th term. That's how you do it. Done. So for this one, we're given an explicit formula, and they want us to write out the first 5 terms of the sequence. So what I'm going to do is I'm going to plug and chug 1, 2, 3, 4, and 5 into n. So when we plug in 1 in for n, we get 24 minus 4 times 1, which is 20. And then you can see that every subsequent term, we're going to be subtracting 4. That's the common difference. Now verify it with this. Plug in 2, we get 24 minus 2 times 4, which is 8. 24 minus 8 is 16. So you see the drop here is by 4. So we can then say 12, 8, and 4. Those are the first 5 terms. That's how you do it. Done. For the following exercises, write an explicit formula for each arithmetic sequence. So check it out. It looks like it's going up by 2 every time. That's the common difference. And a sub 1 is equal to 3. So to get the explicit formula, it's a sub n equals the first term, 3, plus that common difference of 2 times n minus 1. Now what they did in the back of the book is they simplified by distributing. We got a sub n is equal to 3 plus 2n minus 2. These guys will combine to be 1, and therefore a sub n is equal to 1 plus 2n for the win. Boom, done. For this one, it looks like the common difference every time is 100. So it's adding by 100 each time. And my first term is negative 5, which means my explicit formula is a sub n equals that first term, negative 5, plus my common difference times n minus 1. Now we can distribute and simplify. So that's negative 5 plus 100 n minus 100. So combine these two guys together and we get a sub n is equal to negative 105 plus 100n. That's how you do it. Done. So for this one, the common difference is it's adding by 1.8 and the first term is 1.8 as well. So a sub n is equal to the first term, 1.8 plus the common difference, 1.8 again, times n minus 1. As we distribute, we get 1.8 plus 1.8n minus 1.8. These two will cancel out and we're left with a sub n equals 1.8n for the explicit formula. That's how you do it. Done. For this one, the common difference is 2.7, right? Every time we're adding 2.7, again, 2.7, so on and so forth. And that's my original first term. So we're going to have a sub n is equal to my first term, 15.8, plus the common difference, 2.7 times n minus 1. Let's distribute and simplify. 15.8 plus 2.7n minus 2.7. These two will combine to become 13.1 plus 2.7n, and there's your explicit formula. That's how you do it. Done. So for this one, it looks like our first term is 0 and our common difference is 1/3. It's going up by 1/3 every time. So we'd say a sub n is equal to 0 plus the common difference 1/3 times n minus 1. We're going to distribute, and we get a final answer of a sub n equals 1/3 n minus 1/3. That's how you do it. Done. So for this one, we're meant to find the number of terms given in the finite arithmetic sequence. So right now we got 1, 2, 3, and 4. We just got to figure out all the values in between. Now, looking at the common difference, it looks like it's going down by negative 7 or subtracting 7 every time. So let's fill in all the values here. So we'd have negative 18, negative 25, negative 32, negative 39, negative 46, and negative 53, and then we get negative 60. So we got 4 terms plus an additional 6 terms in the middle, which means we've got a finite arithmetic sequence of 10 terms. That's how you do it. So for this one, we've got a bunch of terms from 1/2 to 8. Now we could write them all out and kind of figure out where we go in terms of the number of terms here. But I got a better idea. What I'm going to do is I'm going to figure out what number term is 8 in this sequence. So we can write an explicit formula. A sub n is equal to my first term 1/2 plus the common difference, which looks like it's adding by 3/2 or 1.5, right? 1.5 plus 1/2 is 2. So we say 3/2 times n minus 1. So I want to know what n number or n value is going to give me 8 as my aids to the a sub n term. So we're going to plug in 8 here and solve for n. So I got 1/2 plus, then we're going to distribute 3/2 n minus 3/2. Then we're going to combine these guys. 1/2 minus 3/2 is negative 1. So we got 8 is equal to negative 1 plus 3 over 2n. Now we're going to add 1 to both sides like so, and we've got 9 is equal to 3 over 2n. Last but not least, let's isolate n by multiplying by the reciprocal of 3/2, which is 2/3. Goodbye. 2/3 of 9 is 6. So n is equal to 6. That's the 6th term in the sequence, meaning this finite sequence has 6 terms, and that's how you do it. Done. So for this one, we're trying to figure out if the graph represents an arithmetic sequence where that x is the n, right? That's the first term, second term, third term, fourth term, and fifth term. Now, right from the look of it, if this is going to represent an arithmetic sequence, this is what we should see with the points. We should see a nice line. It should be linear. This instead looks like it's exponential. But the other way that we can verify that is look at the common difference. It's not consistent. From 1.5 to 2.25, it's 0.75. Then from 2.25 to this, it's going up by 1.125. So you can already see with those two terms, it's changing. It looks more exponential than it does linear. So anyways, we'll say no, it's not an arithmetic sequence. Done. So for this one, we're going to write out the first 5 terms using this recursive formula. So we're starting with a sub 1 is equal to n, and then every subsequent term, it looks like we're minusing by 10. That's what the recursive is telling us. So 9 minus 10 is negative 1. Then we'd have negative 11, negative 21, and negative 31. Now to see these terms graphed, I did that in Desmos. So you can see 1, 9, 2, negative 1, 3, negative 11, 4, negative 21, and 5, negative 31. So for this one, we know that the sequence is a sub n equals 3n minus 2 for the explicit formula. So we're going to use Desmos to get these first 7 terms. Let's do that now. So to show the first 7 terms using Desmos, I kind of made the graph as a linear equation, f of x equals 3x minus 2. And then down here, I put 1, 2, 3, 4, 5, 6, 7 for those n values. I just called it x1. And then here's that explicit formula, 3x1 minus 2. And here are the terms of the sequence, 1, 4, 7, 10, 13, 16, and 19. That's how you do it. Done. Now again, for this one, we want to show the graph of the first 5 values of this sequence. So we already got it queued up in Desmos. I'm going to show it to you again. So check it out. There's that linear equation. We don't really even need that, but here are those first 7 terms. Now, in this one, they only want the first 5, so we could get rid of this and this. And there are the first 5 terms. And that's how you do it. Done. So for this one, the explicit formula is a sub n equals 1/2 n plus 5, and we're going to show this using Desmos. So here are the first 5 terms, and I believe they made a little mistake. I think they said this was 4, 7.5. In the back of the book, it should be 5, 7.5. But anyways, that's how you do it. Done. So for this one, it says give 2 examples of arithmetic sequences whose 10th terms are 206. So the first one I'm going to give an example of is going to be pretty straightforward. So one example would be to make my first term 197 and then a common difference of 1, and then we can multiply this by n minus 1. This would provide me with 206 as a 10th term. You can verify that by plugging in 10. 10 minus 1 is 9, times 1 is 9, plus 197 is 206. Another example that they give in the back of the book is pretty straightforward. We just take 20.6 times n. So my first term would be 20.6. My second term would be 41.2. But the 10th term, when I plug in 10 for n, that'd be 206. So these are just 2 examples of essentially infinite examples, but that's how you do it. Done. Find the 11th term of the arithmetic sequence. So we got first, second, and third terms here. Now, the first thing I need to do to get the explicit formula is I need to get the common difference, meaning what am I adding to 1 to get to 2? So I'm going to do the second term, a plus 2b, minus the first term, 3a minus 2b. So we're going to distribute that negative. A minus 3a is negative 2a. 2b plus 2b is positive 4b. So that's my common difference, and that's my first term. Guess what? I can now make an explicit formula. A sub n equals my first term, 3a minus 2b, plus the common difference, negative 2a, plus 4b times n minus 1. Now to get the 11th term, I'm going to take 11 and I'm going to plug it in right here. 11 minus 1 is 10. So then let's distribute that 10 here. We got negative 20a plus 40b. And now all of this is being added to that 3a minus 2b. So now it's combined like terms. 3a plus negative 20a is negative 17a. Negative 2b plus 40b is 38b. And that is your 11th term. That's how you do it. Done. At which term does the sequence begin to have negative values? All right, so first let's figure out what the common difference is. It looks like 17 over 3, then something over 6. Let's get them all to be over 6. So that's going to be 34 over 6, 31 over 6, and then that would be 28 over 6. So what we see is we're obviously dropping by 3 over 6 or 1/2. So the question is 34 over 6 minus a number of 3 over 6s or 1/2, right? And the question is how many of these or what value of x is going to first give me a negative value? And by the way that I can match this up so that it's going to actually give me the right number in the sequence, I'm going to say x minus 1. So that means if I plug in 1, I'm going to get this for my first term, so on and so forth. So let's think this through, right? 34 minus 33, meaning if I multiply this by 11, it's still going to be positive. But if I multiply this by 12, I'm going to get 36 over 6. 34 minus 36 is negative 2. So the question is, what is going to give me that 36? I need a 12 here, and to get a 12 here, x needs to be 13. So check this out. If I do 13 minus 1, it's 12. 12 times 3 over 6 is 36 over 6. 34 over 6 minus 36 over 6 is negative 2 over 6, or negative 1/3. So that's going to be the first term that's going to be negative. And again, that's going to be the 13th term. So that's how you do it. Done. So for this one, we're going to create an arithmetic sequence using a recursive formula. So let's make our recursive formula a sub n equals a sub n minus 1, meaning the previous term. And let's just make it plus 2. So I'm just making something up. So every time we're going to increment by 2. And we're going to set our a sub 1 to 1. Okay, again, this is all just arbitrary. Now, if a sub 1 is 1, that means the first term is 1, the second term is going to go up by 2, it's going to be 3. The third term is going to be 5, and the fourth term is going to be 7. So we got 1, 3, 5, and 7 for the first 4 terms. Now we need to find the 31st term. So a quick shortcut for this is we see that for the second term, we're adding 2. For the third term, we're adding 4. So basically what we can do is we can do 31, right, minus 1, okay, and then we're multiplying that by that common difference of 2. So that's 30 times 2, which is 60. And then to get that 31st term, we take this amount, we add it to the first term, and we get 61 for the 31st term. That's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.